All right, Unit 1. Example 1. Your instructions say to solve and graph. Example 1 you cannot solve because there's no equal sign, so we're just going to simplify it. So example 1, you have 24x plus 15 all over 3. So looking at example 1, the only thing we can do is simplify because there's no equal sign. So does anybody see anything that we could possibly do?
GCF?
There's a GCF in the top. What is the GCF? A 3. So factor out a 3. Now when I take a 3 out of everything, what does that leave me with? I have 24x and I took out a 3. What's that give me? 8x plus 5. All over 3.
You don't take it out of the bottom?
There's only a 3, but what happens?
They cancel.
Well, they don't, it's technically not canceling, it's reducing. So reduce the 3's, and what do you end up with? 8x plus 5. That's it. We can't graph this one. That means for the next ones. Yeah. So we will graph on the next one. Okay? Example 2. 7 times 2x plus 5 minus 6 times x plus 8 is greater than 7. What do you think we could do first in order to solve? Distribute. So distribute the 7 and also distribute the negative 6. So that's going to give me 14x plus 35 minus 6x minus 48 is greater than 7. What would be your next step? We have 14x minus 6x. What's that going to leave you with? 8x. And positive 35 minus 48 gives me negative 13, greater than 7. You guys should be able to solve the rest. What would you do next?
Add 13.
Add 13. And then divide by 8. So that gives me 8x is greater than 20. And when I divide by 8, I get x is greater than, does 20 over 8 reduce? Yeah, to what? 5 over 2. Now your instructions did say to graph this one. So box that answer and then let's draw a number line. Now, I'm not super picky with your graph, so let's just put a line and label it 5 over 2. And this is telling me that x is greater than 5 over 2. So, what type of dot am I going to put? A solid or an open one?
Open.
An open one. And if my x's are supposed to be bigger than 5 over 2, am I going to go to the right or am I going to go to the left? To the right. Because that's where the numbers get bigger, is to the right. So that's how you would graph that. Okay? Okay, example 3. Absolute value of 2x plus 4 is equal to 16. Okay, now remember, with absolute value, when I take the absolute value bars down, I set the whole thing equal to what? What happens to absolute value? When I put, it makes the answer positive. So if I were to take the absolute value bars down, I set the whole thing equal to positive 16 and negative 16. Why negative?
Because it's possible.
Because if I take the absolute value of negative 16, I would still get an answer of positive 16. Okay, so you have to consider both situations. So what I want you guys to do right now is solve each of these. Solve for positive 16 and solve for negative 16. Okay, guys, let's look at positive 16. What would you do first to solve? Subtract 4. So that gives me 2x equals positive 12. And then what do I do?
Divide by 2.
Thank you. Divide by 2. So you get x equals 6. Okay, let's do negative 16. You would do the exact same steps. So subtract 4. And that gives me 2x equals negative 20. So when I divide by 2, I get x equals what?
Negative 10.
Negative 10. So my two answers are x equals 6 and x equals negative 10. To graph that, draw your number line. Just put a point at negative 10 and a point at positive 6. I'm not picky. Make sure you put them in the right order. And if my x is equal to positive 6 and equal to negative 10, what type of dot will I put?
Closed.
Closed. Will I have to put any arrows?
No.
No, because it's just those 2 points. Nothing bigger, nothing smaller, just those 2 points. All right, example 4, we have 2 times the absolute value of x plus 4 plus 1 is greater than 11. Okay, so this time we have an absolute value with an inequality, so remember that makes our answer, you either have to have an and or an or in it. But the first thing we have to do is just get the absolute value by itself. So I have 2 times the absolute value of x plus 4 plus 1. Do you guys remember, am I allowed to distribute into the absolute value?
No.
No, so leave the 2 out there. What would you do first then to solve? Yeah, subtract 1 first. So that gives you 2 times the absolute value of x plus 4 is greater than 10. And then what would you do? Divide by 2. So please do not distribute into the absolute value. Just divide it out. So that gives me the absolute value of x plus 4 is greater than 5. Now, anytime you have absolute value, whenever you split it up into a positive and a negative. So this is x plus 4 is greater than 5. Now my symbol was greater, so what word are you going to use? Or. Great or. So write or in between. X plus 4. Now we want to change that positive 5 to a negative 5. So what happens to my inequality? It flips. So x plus 4 is greater than 5 or x plus 4 is less than negative 5. When we graph this, the answer should mimic this. So to solve, subtract 4 from both sides. So we get x is greater than 1, or make sure that or is part of your answer. X is less than negative 9. Let's graph it. So draw your number line. Put a point at negative 9 and put a point at positive 1. Do our inequalities have equal signs? So are they going to be open or closed? Both of our dots are going to be open. Now, let's look at x greater than positive 1. So we're looking at this one first. What numbers are greater than positive 1? To the right or to the left? To the right. So draw an arrow to the right. And what numbers are less than negative 9? To the left. So your graph is going in 2 opposite directions, and our algebraic answer has 2 opposite directions, greater than 1 or less than negative 9. So your graph and your algebraic expressions should mimic each other. They should look the same. Okay? Example 5. Absolute value of 2x plus 1 is less than 13. Question, is my absolute value by itself?
Yes, indeed it is.
Yes, so I take down the bars, and we have 2x plus 1 less than 13. Now my symbol was less than, so what's your word? And or? And. 2x plus 1, what happens? It flips and changes positive to negative 13. Solve each one of those individually for me. All right, guys, let's do less than positive 13 first. What would you do to solve? Subtract 1. So that gives me 2x is less than 12. And then when I divide by 2, I get x is less than what? 6. And let's solve this guy. Subtract 1 from both sides. So 2x is greater than what? Negative 14. And then divide by 2, so you get x is greater than negative 7. Now, when our word was and, this was a special case. What did we do when our word was and?
You gotta put
Yeah, so you put the x in the middle, put your inequalities going the same way. Now, which number is smaller here, negative 7 or 6?
Negative 7.
Negative 7, and 6 is larger. And the reason we do this is because when I graph these two, let's do a negative 7 and a positive 6. Both of these are open dots. Now, x is less than, or I'm sorry, negative 7 is less than x, so that means everything is going to the right. But x also has to be less than positive 6, so it's going to the left. So where does my answer fall? All the stuff in between. So if your word is and, your x is in between your inequalities, so your answer is in between your points. If your word is or, your inequalities are separate, so your graph should be going two separate directions. Okay? Okay, so Unit 2, when we did this, we combined Units 1 and 2 together, but Unit 2 was all about graphing our lines and our inequalities. So we had two forms of the line, so I want you to write these guys down. We had slope-intercept form, okay, and slope-intercept form was y equals mx plus b. Okay, so in slope-intercept form, that's y equals mx plus b. M is your slope, and b is your y-intercept. So graphing something in that form was really, really easy. You graphed the y-intercept, you counted the slope, and plotted the second point. Okay? If your line was in standard form, that is ax plus by equals c. So that means your x and your y are on the same side. To graph, you would use x and y intercepts. Okay, so if you were in slope-intercept form, the graphing was really fast. If you were in standard form, there's a little bit more work, but it's still not that bad. But you're going to use x and y intercepts. Okay, so write those two forms down, and then here is your first example. You will have to graph. So let's look at this inequality. We have 2x plus y is less than 6. My x and y are on the same side. So is this in standard form or is it in slope-intercept form? Standard. So we're going to use x and y intercepts. So remember, to do x and y intercepts, I make a t-chart and label one side x-intercept and label the other side y-intercept. Now to find the x-intercept, we plug in what for y? The x-intercept is crossing the or the x-axis, so that's where y equals 0. So you're going to plug in 0 for y. So 2x plus 0 is less than 6, or we can change it to equals for right now, because we're just finding the point. So that gives me 2x equals 6. So what does x equal?
3.
3. So plot that point right now. Plot x equals 3. 1, 2, 3. Okay. So to find the y-intercept, we plug in 0 for x. So that's going to be 2 times 0 plus y equals 6. 2 times 0 is 0, so that gives me y equals 6. So plot that point. So you're going to go up 1, 2, 3, 4, 5, 6. 2 points is enough to make a line. So let's look at our problem. Less than 6. What type of line is that going to be? A dotted line or a solid line? A dotted line. So draw a dotted line through those points. And remember, with inequalities, we also had to do shading. Where are my points less than 6? Is that above the line or below the line? Below the line. Because everything that's less than that line is below it. So that's your answer. Okay. Example 2, another graph. This time your inequalities are x is greater than or equal to -4, and y is less than or equal to +3. And we want to graph the solution of both of those. Let's graph x is greater than or equal to -4 first. There's just an x here. There is no y. So that means my graph never crosses the y-axis. So what type of line would this be? What type of line does not cross the y-axis at all?
Oh, the ones that do that?
Okay, horizontal would cross the y-axis. Vertical will not. So this is a vertical line through the point -4. So graph that. 1, 2, 3, 4. And it's solid because there was an equal sign underneath your inequality. Now your second one, y is less than or equal to +3. There's no x in there. So what type of line would that be? Horizontal. So through the point +3, you're going to put a horizontal line. But we need to make sure, because we have inequalities, our solution is the shaded area covered by both. So if my x's are greater than -4, is that going to be to the right of the orange line or to the left of the orange line?
To the right.
To the right, everything bigger than the orange line. But my y's have to be less than +3. So is that below the green or above the green? Below. So our answer is everything to the right of the orange line, but below the green line. So it's this area right in here. Okay guys, so looking at our first inequality, 2x plus 3y is less than or equal to 12. Is that standard form or is that slope-intercept form?
That's standard.
That's standard. So we're going to use x and y-intercept. So make a t-chart. Okay. Now to find your x-intercept, we plug in 0 for y. So that's going to be 2x plus 3 times 0. And then we can just change it to equals 12 because we're just looking for the point. So that's 2x equals 12. So what does x equal? 6. So graph x equals 6. Okay. What would I plug in for x to find the y-intercept? 0. So this is 2 times 0 plus 3y equals 12. So that's 3y equals 12. So what does y equal?
4.
4. So go up 1, 2, 3, 4. Now is this blue line going to be solid or dotted? Solid. And then we're not going to worry about the shading just yet. Okay, because we still have a second line to do. Y is greater than or equal to x minus 6. What form is that in? That's in slope-intercept. What's the y-intercept? Negative 6. So go down 1, 2, 3, 4, 5, 6, and put a point. This is slope-intercept form. So y equals mx plus v. So b is negative 6. What's y or m? 1. So you're going to go up 1 over 1 and put a solid line through that. Okay. Now we have two inequalities here. So there is going to be some shading. At the blue line, everything is less than or equal to. So is that below the blue line or above the blue line? Below. So we're going to look at everything below the blue line. But are we going above or below the purple line? Above. So everything below the blue line but above the purple line is part of our answer. So it's all that space in there. Example 4, we have a system of equations. 2x plus y equals negative 4, and 2y minus 7 equals negative 4x. Okay. Okay, for systems of equations, we had two methods. We had substitution method and we had elimination method. Does anybody have an idea of what might be easier for this problem? Elimination?
Yeah.
For elimination, we would have to get x and y stacked and then be able to eliminate. But we have x on one side and y on the other side over here. But we do have a y almost by itself. How could we get y by itself?
If you subtract the 2.
Yeah. So on the top equation, subtract 2x. And that gives me y equals negative 2x minus 4. We can use that to substitute in for y in the second equation. So I always put parentheses around it. And we're going to take this whole expression and substitute it in for y in the second equation. So that's going to give me 2 times negative 2x minus 4 minus 7 equals negative 4x. And what would you guys do to solve for x? Distribute. So distribute the 2.
Would you combine like terms?
Then you would, after that, you would combine like terms. So that's negative 4x. Hold on. Minus 8 minus 7 equals negative 4x. And then Ryan said combine like terms. So that's negative 4x minus 15 equals negative 4x. And then why would you say they crossed out, Ryan?
Because if you add 4x, then you add 4x.
Then you get negative 15 equals what? 0. Is that possible?
No.
No. So what would your answer be?
Not a solution.
No solution. Okay, so we have 5 binders and 3 pencils cost $13.10. How would you write that as an equation? 5b plus 3p equals 13.10. And then we have 2 binders and 6 pencils that cost $6.20. So how would you write that? 2b plus 6p equals 6.20. Okay. What method would you want to use here? I would use the elimination method. Look at your b's and look at the p's. What might be easier to eliminate? P. What would you multiply the top by then? Good, -6. So rewrite, thank you, we're making it into a -6. So multiply everything by -2. So that's -10b minus 6p equals -26.20. Do we have to change the bottom equation at all?
No.
No, so just rewrite it. Okay. So when we add straight down, -10b plus 2b, what's that give you? -8b. -6p plus 6p gives you? Cancels. -26.2 equal, or plus 6.2 gives me -20. And then how would we solve for b? We would divide by -8. And that would make it a positive. Now, we are dealing with money, so make sure you put the $sign. 8 goes into 20 2.5 times, so 2.50. So a binder costs $2.50. Okay. How do I solve for how much a pencil costs?
You could plug it into...
Plug it in. Any preferences?
2b plus 6p.
2b plus 6p. So that's going to be 2 times 2.50 plus 6p equals 6.20. So that's 5 plus 6p equals 6.20. Subtract 5. So that 6p equals 1.20. And then when I divide by 6, I heard you say it, Ryan, what did you get? P equals 20 cents. So 0.20. So pencils are 20 cents, binders are $2.50. Last one, systems of 3. We have 2x minus 2y plus 4z equals 6. 4x plus 2y plus 8z equals 12. And 4x minus 2y plus 8z equals 12. Remember, the first thing I always did was number my equations. And whenever you have 3, we're going to use elimination method, okay? So to use elimination on a system of 3, we have to remember to cancel the same variable both times. Because remember, we're going to pair 2 together, and then we're going to pair 2 other equations together. Look at your variables, guys. Does any one stand out to you?
2y.
The y's. So which 2 do you want to pair first?
The first 2.
The first 2. So label it 1 and 2. And let's pair 1 and 2 together. So that's going to be 2x minus 2y plus 4z equals 6. And 4x plus 2y plus 8z equals 12. X plus 4x, what's that give me? Okay, 6x. Negative 2y plus 2y cancels. And 4z plus 8z gives me 12z equals 18. Circle it. That's as far as we can go with that one right now. So then we're going to pair 2 more equations, but eliminate y's again. So which one do you guys want to pair? Yeah, I would do 2 and 3 because we won't have to change anything with the y's. So that's 4x plus 2y plus 8z equals 12. And 4x minus 2y plus 8z equals 12. That's going to give me 8x, y's cancel, plus 16z equals 24, and then circle that one. So I was able to get rid of all the y's, and now I am left with 2 equations that only have x and z. So let's pair those together. So 6x plus 12z equals 18, and 8x plus 16z equals 24. What variable do you guys want to eliminate, x's or z's? Z? Okay, so what would we need to get them both equal to? What can we turn 12 and 16 both into? You want to do x instead? Okay, so 6x and 8x, how can we get those? 24, right? Okay, so that would mean we multiply 6x by 4, so that's 24x plus 48z equals 50, no, 4 times 8 gives me 32, 72. So what would I multiply the bottom equation by? We want to eliminate x's, so we're going to multiply by -3 to make it 4 times 8 is 30, no, 6, so that's -24x minus 3 times 16, 18, 48 equals 3 times 24, -72. So when I add both of these together, what do we end up with? The x's cancel, the z's cancel, and this cancel, so 0 equals 0. Is that a true statement?
Yes.
So how many solutions do we have? Infinitely many. So you can stop there. So infinitely many solutions means that all three of these lines actually are the same line because they cross over with each other. Okay?